Continue our study here today of solving a system of equations. We are going to talk about solving a system of equations here by substitution. And when we substitute, we want to find an equation that has a variable by itself. Now, in this particular example, we got kind of an overachiever here because right here on this side of the equal sign, I have a y by itself. On that side of the equal sign, I got an x by itself. Here I also have a y by itself, so I got three variables by themselves, and I only need one. So I'm going to pick one and say, well, here's a y. And that y is equal to x. Well, where there's a y, I'm going to replace it with the x. So over here in my other equation, when I run into a y, which is right there, I'm going to get rid of that y and replace it with x. So I'm going to rewrite this equation with the x in for y, and it's equal to 2x plus 3, just bringing everything else down. Well, to solve this, we need to get the variables all to one side, number terms to the other. The 3 is already on the right side of the equal sign. The 2x, I'm going to move it by subtracting it on each side, so minus 2x here as well. And as I subtract that on this side, I've got negative x. 2x and negative 2x are going to cancel out, and it's equal to 3. As we've talked about before, this is really a negative 1. So we're going to divide by negative 1, and dividing by negative 1 is pretty simple. The only thing that happens when you divide by negative 1 on each side is the signs switch. So the x becomes positive, the 3 becomes negative. So I have an x value here of negative 3. Well, I'm going to take that x value of negative 3, plug it in to one of the equations. I'm going to choose this one here because it's just a lot easier to work with than the other one. And so where there's an x, we put the negative 3 in. So y equals x, or y equals negative 3 as I substitute that in. So you have an x value of negative 3, a y value of negative 3 for an answer of negative 3 and negative 3. Like I stated earlier, this is just a different method of solving. Last time we talked about graphing. Had I graphed those two lines, not real sure what those lines would look like, maybe without the graph, but I do know one thing, that they would intersect at that point of negative 3 and negative 3. As I take a look at example 2, keep in mind you're looking for a variable by itself in order to substitute. There's a y here by itself on this side of the equal sign. I have a y by itself here on this side of the equal sign. So I could choose either one. I'm just going to choose this one here out of convenience. Y is equal to, what's it equal to? Well, it's equal to this whole expression of 3x minus 10. So that means over in my other equation where there's a y. I'm going to underline it because that's what's getting replaced. And in its place, I put 3x minus 10. Bring the y down as 3x minus 10. I bring the equal sign down. The 2x minus 5 comes down. And then as I solve this, I want to get all my variables over here to one side. So I'm going to minus the 2x to make that happen. So if I minus 2x there, I got a minus 2x on the other side, keep my equation in balance. And if the variables are moving to the left, that means my number terms have got to move over here to the right. So we add 10 to each side. We add 10 under each of those. So as I do this, I've got 3x minus 2x at, well, that gives me x. The 10s reduce out or cancel away, equals, and the 2x minus 2x cancels out, and I've got negative 5 plus 10, which ends up being a positive 5. I take that x value of 5 and I plug it into one of my equations. It doesn't matter which one, since this one has nothing underneath of it. It's convenient to work with. So I'm going to put this x in place, and it's going to be y equals 3 times x, or 3 times 5, since that's what we found it was equal to. Subtract the 10, and as I simplify this, y is equal to 15 minus 10 when you multiply the 3 times 5, and in the end, y equals 5. Well, we're looking for the place of intersection. We have found that. You've got the ordered pair, x value of 5, comma, y value of 5. So these two lines, if graphed in the coordinate plane, would intersect at the point of 5 and 5. Taking a look here in my next example, the big thing for substitution, we said we are looking to find an equation that has got a variable that is by itself. The first equation has exactly that, so I've got this y by itself. It's equal to x minus 7. So over in my other equation where there's a y, right here, I'm going to replace it with x minus 7. So as I substitute in, I bring my 2x down, I bring my plus sign down, and in for y, I'm putting an expression. It's a good idea as you put this in to put it in parentheses. With the addition, it's really not going to make a big difference because if I add x minus 7, would not really make a huge difference, but it would if it's subtraction. Because what I have to do is take this sign, which is a positive or positive 1, and it gets distributed in. And as I distribute that in this case, nothing happens, and the negative or the 1 times the x is just a 1x, so plus x. And as I distribute the positive 1, if you will, into the 7, it'd give me negative 7 still. Now, the reason I'm suggesting we put it in parentheses is because when there is a negative here, it does make a big difference because these signs would both change, and mistakes are typically made when we don't put it in parentheses with that negative if it had been there. Anyway, from there, we continue simplifying both sides. The 8 is obviously simplified, but over here, on this side of the equal sign, I have got two x terms, and when I put those together, we get 3x, and so the minus 7 comes down, equal to 8. We add the 7, add the 7, and we end up with 3x is equal to 15. Well, to solve this, final step here to get an x by itself, we're going to divide by 3 on each side. So divide 3, and your x value ends up equaling 5. Well, with that x value of 5, we're going to take that, substitute it into one of the other equations. I'm just going to use the first one here because it's convenient. The other one would work fine as well. And I'm going to plug in where there is an x. Since x is equal to 5, I'm going to put that in place here. And I'm going to put y is equal to 5 minus 7. So my y value ends up being 5 minus 7, and 5 minus 7 is a negative 2. So final answer on this, I've got x is 5, and y is negative 2. So graph those two lines in the coordinate plane. That is the place that they were going to intersect. A little extra scratch there on the board. I'm doing undo for that guy. And here we go. On to our next problem. Number 4. All right, example number 4. Much like we've talked about here, we are looking to find a variable by itself. I don't have it in the first equation. It's in standard form. But I do here in the second one. I've got the y by itself. So y is equal to this expression of negative 2x plus 4. So in my other equation right here where there's a y, I'm going to replace it. Everything comes down. 4x plus 2 times your y. I remember when we plug in for the variable, I told you I like to put this in parentheses. It's going to be important here because in this case, I am going to have to distribute that 2 into everything. So there we go. We got the y substitute in for, so the 8 and the equal sign simply come down. To solve this, we distribute. I've got 4x. As I distribute my 2 into both terms, I've got negative 4x. 2 times 4 is a plus 8. And it still equals 8. As I continue simplifying, I see here I've got a 4x and a minus 4x. Those are like terms that combine together. Well, that gives us 0x. Well, 0x, really sweet, and a card from Granny, hugs and kisses. We love to have that, but in algebra, we really don't need to write 0x because it doesn't have any value. So I'm just going to erase that and continue on here. And we're going to have this 8 equals 8. I'm going to stop at that point because the variables are gone. And I've got this statement, and this statement that I have here in front of us happens to be true. And it's always true. And so if you end up with some statement like this where the variables are gone, you got a true statement, this is the case where you have an infinite number of solutions. And so we write infinite solutions. And basically what that means is if I were to graph those two lines, it would be the exact same line twice. Okay. No further, nothing else further to do on that one. And so we're going to go ahead and take a look here at our last example, number 5. Once again, the method of the day is substitution. The number one thing you're looking for is a variable by itself. So here we go. I got a y by itself. So where there's a y, I'm going to substitute this guy in here. And right here, I've got a y, so I'm going to replace that guy. So I've got 2x plus 3 times my y value. Well, the y value is negative 2/3 x plus 4. Remember, as we're substituting in there, we are putting it in parentheses. And the equal sign comes down. The -6 comes down. And then we start to simplify on this side. And once again, to simplify, we will distribute that guy into both terms. Well, 3 times negative 2/3 x. First of all, 2x comes down. 3 times negative 2/3 is a negative 2x. And then 3 times the 4 gives me a plus 12. The equals -6 just carries down. And as I look at this, I've got like terms to combine again. And much like the last one, these two guys would combine together to give me a 0x, which we don't need to write. It just cancels out. And I end up with, on this side, 12 equal to -6. And when I look at that, that doesn't look quite right. I have got a false statement. Because obviously 12 is not equal to a -6. And if we have a false statement, this is the case where you've got lines that are parallel. This is a no solution. So if you're solving a system by substitution and you end up eliminating the variables away completely, there's two possibilities. One is you got a false statement, which would there be no solution, or you potentially could end up with a true statement, in which case there would be an infinite number of solutions. For all other systems of equations you'd solve, you do like 1 through 3 here, where we got an x value, we found a y value, and your answer was an ordered pair, which was the place of intersection in the coordinate plane. That's it for this one, and we'll talk to you online.